a tricky question here in 2014, question 5, concerning trig functions. So the graph below shows the voltage and electric current as a function of time. So as a function of time, there's where your time is. Down there, your x-axis. Here's your voltage here, and your y-axis. Voltage is given by the formula 311 sine 100 pi over t. And just be careful, once they give you your pi like this, we know we're going to be in radians format. So get shift, mode and 4 for your radians. And when there's a number in front of a sine, cos or tan, we see that it affects the range. So the range is going to be between minus 311 and 311. As you can see from the graph, 311 to minus 311. While this here is going to shorten your period here. Write down the range of the function. So as we said, minus 311 is 311. Difficult to see that exactly from the graph, but that's what this number indicates. How many complete periods are there in 1 second? So the period is the time it takes to repeat itself. So here we can see it repeats itself after 0.02 is your time in seconds. So it takes 0.02 seconds to repeat. Now you're going to have to write that down. So we want to see how many ones of these are in 1 second. So if we kept continuing that on. So how many 0.02s in 1 second? So 1 divided by 0.02, which is 50. So there's 50 periods there in 1 second. Still alright, now it's going to get difficult. So, B part 1. The table below gives the voltage, correct to the nearest whole number, at equally spaced intervals from T1 to T12 over 1 complete period, as shown by the dashed line. So 1 complete period, meaning you're going to 0.02. Use the entries given in the table and the properties of the function to complete the diagram. Now just keep in mind that our function here is 311 sine 100 pi t, or pi's in radians. So you could be saying, like, you can see there are equally spaced intervals. You probably nearly be good enough in guessing what the value is going to be. So T1 here is 156, 269, 311, and then going down in symmetry. So that's going to be minus 2 or plus 269, 156, 0, and then go in the negative direction. You could do this in your calculator as well, just for peace of mind. So mode, let's see, we're in radians, we have mode 3 for your table. Type in your function, 311 sine 100 pi t, which is pi, and we'll just use an x alpha right bracket. And we're starting at here is the first interval, T1. Now T1 in this, it says there's 6 equally spaced intervals between 0.01 and 6. So that means T1 is 0.01 over 6. So I just put that in your calculator, 0.01 over 6. And you get a funky looking fraction, that's alright. And that's, we're going all the way to 0.02, 1 complete period. And then steps are going to do the same. They're all equally spaced. So 0.01 over 6. Now, hopefully we get a table out and we can see we get 155.5, 269.33, 311. So it says the nearest whole number, so we're right enough. And as we said, 269 is just going back down again. 156, 0, minus 156. Minus 269, minus 311, minus 269, minus 156, and 0. And the next part of this, using a calculator, or otherwise calculate the standard deviation. The 12 values, correct to the nearest whole number. Now standard deviations, confusing putting these into the calculator, but We need to know what I'm doing for correlation coefficients. And also mode 2, your stats, to measure variability. So 1, type in your first 12 values, so ones from your table. So 156, 269, 311. You can see the frequencies coming up as 1 if you got the frequency table. If not, you don't need it in this case. 269, 156, 0, minus 156, minus 269, minus 311, minus 269, minus 156, and 0. Once you have all them 12 values put in, you clear the calculator and you go shift 1 for your stats. And again, variability is 4. And there's your standard deviation sign, which is 3. And when you get that, you get 219.89. And this is the nearest whole number, so 220. Now, see part 1. The standard deviation of closely spaced values of functions of the form this. So again, there's going to be your range. This is going to affect your period. Over one full period is given by the following. K, standard deviation is equal to V max. K is a constant that does not depend on A or B, and B is the maximum value of the function, linking into our range. Use the function this. So here, it's going to be the maximum value because the range is going to go between minus 311 and 311 to find an approximate value for K for it 3 decimal places. So K, the V max, just using the formula they give you. Working out K, so we must have everything else. 220 is equal to 311. K is equal to 311 over 220. And 3 decimal places, 1.414. Tricky wee one. There. And then the last bit of this, using your answer. In part C1 or otherwise, find the value of B required. So the function here has 60 complete periods in 1 second. 60 complete periods in 1 second. And the approximate value of A, so there's a standard deviation of 110 volts. So standard deviation of 110 volts. So here, from above, we know that K that is equal to V max. Now in this case, they haven't said it's 311. But if we work out V max, whatever it's going to be the same as A because that it's dependent on your range. So this is allowing us to find A. So K said it was a constant, so it's 1.414. And our standard deviation is 220. So just simply multiply those two together. 1.414 by 220. 311. Oh, sorry. 110 volts, I made a mistake there. Standard deviation 110. Because I ended up with 311. So I realised I must have used it from the last bit. So 1.414 times 110 is equal to V max, which is 155.54. This is actually half it because, again, your 110's been halved. So, approximate value of K. Okay, so that's our value there of A. Now, the next bit here is to find the value of B. A little more difficult in this sense. So here it says it has 60 complete periods in 1 second. So on a normal sine function, the period is 2 pi, or 360 degrees. So that's in a general sine function, or a cos function. Here, because there's b in front of it, your period is going to be 2 pi over b. If it was sine 2x, it'd be 2 pi over 2, which is 180 degrees. Sine 3x, 2 pi over 3, which is 120 degrees. Here, 2 pi over b. And it says complete 60 periods in 1 second. So its period, the time it takes to repeat itself, is 1 over 60. Trying to solve for b, so cross multiply. 2 pi times 60 is equal to 1 times b.
So 120 pi is equal to B.
There's our value of A, there's our value of